Hello everyone. Today I am going to discuss the last problem of AtCoder Beginner Contest 360, which is suitable edit for LIS. So you are given an integer sequence A of length n. Takashi will perform the following operation exactly once. Choose any integer from 1 to n inclusively and an arbitrary integer y. Replace x with y. Find the maximum possible length of of a longest increasing subsequence after performing the operation. So the problem is nothing but we are given an array, anything. Let's say 1 to n. So we can take any index and change the value to anything, and after that we have to find the maximum possible LIS. Now let's take one example, 4 3 2 2 4. So 3 2 2 4, let's say, is the array 3 2 2 4. Initially the LIS longest increasing subsequence is nothing but 3 and 4. Okay, 3 and 4. Now let's say we change the value of 3 to 1, then our array will become 1 to 2 4, and the longest increasing subsequence will be 1 to 4. So our desired answer is 3. Okay, you can take other examples. So the problem is, first glance problem at first glance is quite easy. That the answer could be the current LIS in the array. Okay, the current LIS in the array or current LIS plus 1. Why it is like this, LIS and LIS plus 1? Why it could not be less than LIS? Because one possible way to take is that, let's say we have some LIS, let's say P1 till Pn. Then one possible transformation is change P1 value to anything less than P1, then the answer LIS is possible. And another thing is that when LIS plus 1 is possible, then we have to take the case. Now at first glance you can think that always LIS plus 1 is possible, that the answer should always be LIS plus 1, but that is not the case. Let's say there is a special case where it is like this: 1 2 1 3 and 4. So the current LIS is nothing but 1 2 3 4, right? Current LIS is nothing but 1 2 3 4. Now you can't change this value to anything. You can't change this value to anything such that the LIS of the changed array is 5, or you can't change actually any index to anything such that the LIS becomes 5. Okay, so the answer could be LIS and LIS plus 1, but we have to decide when it is LIS and when it is LIS plus 1. Okay, so this is the first observation. Now what is the second observation? Second observation here is that when the answer LIS plus 1 is not possible. The answer LIS plus 1 is not possible if in the LIS all the elements are adjacent. Let's say 1 2 3 4. It could be like L plus 1, L plus 2 and L plus 3. Okay, like that. So in that case we can't change anything between them. We can't change anything between them. uh, we can't change anything between them to have LIS greater than the current the entire array's LIS. Okay, that is the one case. Now let's say there are some values after that, or there is some value before this, then it is possible to change. Let's say there is some value, let's say 5 here, we can change this to 0. Or let's say there is some value, let's say 1 here, we can change this to 5. Okay, but anything between them it is not possible to change. Anything between 1 and 2 we can't change. Anything between 2 and 3 we can't change, and anything between 3 and 4 we can't change. Okay, so here I thought about one approach is that we'll take two type of DPs. One is DPI0, one is DPI0, and another one is DPI1. Now what DPI0 and DPI1 signifies? DPI0 signifies that the longest LIS irrespective of anything. The longest LIS till index I irrespective of anything. That is DPI0. Now DPI1 means that uh, it is LIS, longest increasing subsequence length, but there is a gap between the LIS. There is a gap between LIS. For this, the LIS could not be 4. The LIS could be LIS DPI1 could be 3. Okay, because there is no gap between I and I minus 1. Okay, so I hope you get it. And this one is DPI0 and this one is DPI1. Okay. Now if there is, if DPI0 and current index I is less than n minus 1, we can take LIS plus 1, right? We can take LIS minus 1 because we can increment the last index value by 1. Now if DPI1 if DPI1 is something, then we can increment the value by 1. So we can change the value by 3 to 4. Okay, because there is a gap between any two index. Okay, I hope you get it. Now let's jump onto the code. Here I am doing coordinate compression. So for how we can find dpi0 and dpi1, that is one important part. Let me take one moment. Now for finding dpi0 and dpi1 value, what we can do, because we have to find the value which is ai, which is less than ai minus 1. Okay, so for that what we can do, we can do some kind of coordinate compression. Okay, let's say we have something like one, let me explain you. Let's say we have something like 2, 10, 11, 14 and 15. Okay, so we can coordinate compress it to, from value 2 could be 1, 10 could be 2, 11 could be 3, 14 could be 4 and 15 could be 5. After that we can take I as this mapped value. Okay, so dpi0, this dpi0 value will be anything. Dpi0 value could be dpi minus 1 0, dpi minus 1 0 plus 1, right? Dpi minus 1 comma 0 plus 1, because it is something less than ai something less than ai plus 1. And dpi1 could be, one thing is that we can take dp I minus 1 and 1, because we have already taken one space. Okay, let's say we have already taken, let me explain it here. So let's say 1 3. Okay, 1 3 4 5. Now for finding this value we can take dp I minus 1 1, because we have already taken a gap. Okay, so dp I1 is nothing but, we can take dp I minus 1 1, I minus 1 1, or we can take dp I minus 2 and 0. We can take dp I minus 2 of 0 plus 1. Okay, we can take maximum of these 2 plus 1. Why I am doing that? I think you understood that if dp I minus 1 1 means that we have already taken one gap, so it is not necessary that we have to take another gap. So we can take 4 after 3 as well. But if we have not taken any gap, we can do dp I1 as dp I minus 2 comma 0 plus 1. Okay, now there is a special condition. Let's say we are coordinate compressing it, right? So 1345 will become 1345 will become our 1234, right? 1234. Here you can see that the previous value of, let's say previous value of 3 is not 2. Okay, so if we are taking dp I minus 1 in this index, we can take 1 and there would be a gap. Okay, so there is a specific case that if the previous of current index, if the previous of current index ai is not equals to ai minus 1, then we can take dp dp I minus 1 0 as well. We can take dp I minus 1 0 as well, only when previous of ai is not equals to ai minus 1. This is one specific case. And there is other case when we can update this value. Let's say something like we have encountered 134. Okay, now here you are saying that this is dp I1 value. Dp I1 value means there is a gap and we can increment that, but there is no space to increment, right? Let's say there is something between this, there is something between this, let's say 5, let's say this is 1534, then there is a space, we can increment that. But if the total sequence length is the LIS length, then we can't increment it. Okay, so in that case we will not update the value of dpi1. So let's jump onto the code. So here I am doing coordinate compression. I think you all know about coordinate compression. We'll push all the elements in a set, and we'll set if the previous is equals to I minus 1, then we are setting that the current element has a previous index which is ai minus 1. Okay, so last of I will indicate that. And we are doing map of I as 3 plus 1. Okay, now our current index is the mapped index, map of ai. Now value 1 will be dpi0. Okay, so we are doing our first segment will contain dpi0 value, so we are doing dpi0 for index minus 1, and we are doing similar thing for this part is not needed, right? This part is not needed because if every time dpi0 will be greater than dpi1. Okay, so this part you can skip. and we are doing one dot update index comma value. Now this is if I less than n minus 1, that means let's say we are at some index 1 2 3, and there is some index, let's say 6 here. Then we can see, we can check, we can say that the current LIS plus 1 could be our possible answer, because we can change the value of 3 to 4 or anything greater than 4. Oh, so that's why we are doing if I less than n minus 1, we are doing value plus plus, and we are taking answer as maximum of answer comma value. Now, if the last of AI is not equals to if 1, that means the previous of AI is AI minus 1. So we are taking the DPI0 query of index minus 2 and the segment 2 query of index minus 1. I have explained why. Otherwise, we are doing I minus 1 query on SM1. This part is not needed. Okay, this part is not needed, because SM1 dot query of 1 comma index minus 1 will obviously be greater than SM2 dot query index minus 1. Okay. Now, if value is greater than 1, so there is no possibility that we take one value, then there is no place to increment here. So if the value is greater than 1 and the current sequence length is less than LIS length, okay, current sequence length is I plus 1 and it is less than it is greater than our LIS length, then only we are doing SM2 dot update index comma value. And if the current sequence length is less than I plus 1, then we can increment the value by 1. Let's say we have something like 1 5 3 4, then we can make this LIS by incrementing the value of this to 2, changing the value of this to 2. Okay, that's why if value is greater than 1 and if I and value is less than I plus 1, we are doing answer equals to maximum of answer comma value plus 1. uh, I hope you got my explanation. You have any doubt in any part of the explanation, you can always ask in the comment section. I will provide the link of the code in the description box. You can check that out. If you like this video, please subscribe to the channel and also share among your peers. Thank you.